return students to the review sheet, help video, page 579. These numbers right here. That's not right, is it? Let's fix that real quick here, if we can. There we go. Let's go ahead and get started. Numbers 1 through 4. I'll tell you right now, some of the pictures did not turn out very well from my camera on this video, so I'll have to fill in numbers. Plus, you have your book too, so you can also look in your book. But anyways, numbers 1 through 4, the directions say to find the perimeter. So notice this side here is congruent to this side here. So this side has a length of 4 like this side. This side here is congruent to this side here, congruent to this side here. This side has a length of 5. So this is 5. This is 5. So we have 4 plus 4 plus 5 plus 5 plus 5. And that would be a total of 23 units. 23 units, okay. Moving on to number 2. Alright, well here we just have 4 sides to add up. So we have 1 plus 1 half plus 3 halves plus 3 halves. Now a lot of you are used to using your calculators, which is fine. I'm going to do it the old-fashioned way. Notice all of my denominators are 2, except for the number 1. So I'm going to make this number 1 become 2 over 2. So now all of my denominators are 2. 2 over 2 right here. 2 over 2 equals 1, so I can do that. So here we go. My denominator stays 2. 2 plus 1 is 3. Plus 3 is 6. Plus 3 is 9. So the answer is 9 over 2. Or 4.5. Or 4.5. Any of those answers are acceptable, okay? Moving on to number 3. Okay, there are some missing sides we got to fill in quickly here. There's, notice this side here is congruent to this side here. So if this side is 8 right here, then this side over here would also be 8. Notice this side is congruent to this side here. This is 4. So that means this side here would be 4. So I have to add up the sides. 8 plus 9 is 17. Plus 8 more is 25. Plus, I'll check these off. Let me start over so you can see this. And here we go. 8 plus 9 is 17, plus 8 more is 25, plus 4 is 8, so plus 8 more is 33, plus 6 is 39, so the perimeter should be 39 units. Alright, number 4, a lot of numbers are missing here. All of my 1 slash lines will be 1.7, okay? So, this is 1.7. This is 1.7, this is 1.7, and this is 1.7. So before I add all of these up, I have 1, 2, 3, 4, 5 1.7s. So I'm just going to take 1.7 times 5, and that will give me 8.5, okay? Then I've got to add to that 2.5 and 1.2. So 2.5, 1.2, and then 3.2. So 10, 14, 11, 12. I did it quickly. I'm getting 15.4. I might have made a mistake somewhere. No, I'm good. So the perimeter is 15.4. Remember, guys, when you're told to find the perimeter of a shape, that means you add up all of the sides on the outside, okay? Okay, students, here we go. Now, first of all, any numbers 5 through 12, we're going to find the area of the polygon. Now, this is a parallelogram. Got it? The formula for the area of a parallelogram. You got to know these guys. You've got to have your formulas memorized. The formula for area of a parallelogram is 1/2 base times height. That's not right. I just told you guys you have to know your formulas. I don't even know it myself. The formula for area of a parallelogram is base times height. Now, take this figure. I know it's cut off a little bit here, and I apologize for that, but nonetheless, you can look in your book, turn it this way, and now you can see your base down here has a length of 11. So there's your base, and your height right here has a height of 6. So the answer is simply base times height, 66 centimeters squared, and that is the correct answer. Moving on to number 6. If you want to find the area of a square, you take length times width or side times side, okay? Well, if this is 2, this is also 2. 2 times 2 is 4 square centimeters, alright? And so, there we go. Moving on to number 7, alright? In order to find the area of a triangle, we use the formula 1/2 this, and I'm going to turn it so we can see things a little better. Just easier that way. I know it's not perfect, but here's my base right here. Here's my height right here. Got it? Pretty simple. So I'm going to take 1/2 times the base times the height. And if you type all of that in to your calculator, you will get this right here, 23.85 centimeters squared. Okay? Alright, moving on. Number 8. This is a rectangle. In order to find the area of a rectangle, you take the length here times the width down here, and that's it. So you would take 5.6 times 8.4. Alright? And it's obviously pretty simple. If you do that correctly, you will get 47.04, which should be the answer up here. Yes, it is. Alright, moving on to number 9. Now, I know this is hard to see, so I'll go ahead and try to fill it in a little bit. There's a line here, right angle here, right angle here, and this is 3 feet right here. This line in green is 3 feet, okay? Now, this is a trapezoid. How do I know that? How do I know this side here is parallel to this side here? Because we learned a long time ago that anytime a line right here is perpendicular to the same two lines, then those two lines are parallel. Or, I think we said this way, if two lines are perpendicular to the same line, then those two lines are parallel. And this line is perpendicular to this line is perpendicular to this line, so this line and this line are perpendicular to the same line, so those two lines have to be parallel. So I have a trapezoid, okay? So as soon as I realize I have a trapezoid, I realize my formula for finding the area of a trapezoid is 1/2 height, and then you add your two bases together. So one base is 6. Remember, it doesn't matter which way the trapezoid is turned. Please don't forget that, students. It does not matter which way the trapezoid is turned. The bases are always the what? The parallel sides. I don't care which way this thing is turned. And the height is always the distance between your two parallel sides. Okay, so your two bases are 6 and 3. So I'm going to go ahead and put a 9. I'm going to add those together. Your height is 3. And then times 1/2. Well, obviously, you would get 27 times 1/2 would be 13.5. So the area 1/2 times 3 times 9 is 13.5 square feet. Alright, square feet. Moving on to number 10. Well, guys, once again, we're finding the area of a triangle, so it's pretty simple. 1/2 times the base times the height. So 1/2, the base is 8.5. The height is 7. So with your calculator, if you take 1/2 times 8.5 times 7, you're going to get 29.75. 29.75. Alright. And let's continue on. That's a pretty simple problem. Let's take a look at number 11. Alright. This one's really hard to see. So let me see if I can fix this for you, okay? Here's your kite right here. Well, you can look in your book and see this, okay? There's your kite. Here's one diagonal right here. Here's one diagonal here. And notice your diagonals are perpendicular. This is 2 1/2 yards. This is 3 1/2 yards. Now, students, listen to me. You learned if any time a quadrilateral has perpendicular diagonals, how you find the area is 1/2 times the diagonal times the diagonal. Let me say that again. First of all, you have to have a quadrilateral, and we have a quadrilateral. Second of all, you have to have diagonals. Two diagonals that are perpendicular. We have two diagonals that are perpendicular. When that happens, use this formula, right? Use this formula right here. So to find the area of this quadrilateral, you would take 1/2 times one diagonal times the other diagonal. Alright? So with your calculator, 1/2 times 2.5 times 3.5 is going to give you 4.375. Alright? And that is the answer right here. 4.375 375 yards squared. Moving on to 12. Okay, we do have another parallelogram. Mr. Earhart, how do you know that? Well, we learned four or five ways to prove that a quadrilateral is a parallelogram. One way that we learned is if both pairs of opposite sides are congruent. Well, this side's congruent to this side, and this side's congruent to this side. So we know we have a parallelogram, okay? So we're going to take, how do you find the area of a parallelogram? Base times height. So the base is 7 right here, and the height, the perpendicular line connecting these two sides here, is 9. So very simply, the area is 63. Pretty simple, 63 meters squared. Alright, moving on to numbers 13 through 20. The directions say to complete the statement. Alright, so we are given a rectangle. They give us the area. They want us to find the height. Well, let's think about this. How do you find the area of a rectangle? Well, it's length times width, or if you want to use the words they use, they're saying base times height. No problem. No big deal. So the area is 36. Put a 36 here. The base is 4. Put a 4 here. And the height is h. Divide both sides by 4, and 9 equals your h. See how I use that formula right there? I just wrote the formula for the area of a rectangle and then substituted the correct numbers in and then solved for my unknown, and the answer is 9. Alright, number 14, we're dealing with a square. So the formula for the area of a square is side times side. Okay, so they give us the area. The area is 3. So I have 3 equals side times side, or in other words, side squared. Let's go over this again. This is the formula for finding the area of a square, side times side. Okay, so where the A is, I substitute 3 for the area. I don't know what the side is, but I know that side times side is side squared. Now I know I can take the square root of both sides to solve for S, and usually when you do that, you put plus minus, but a length is never plus minus, so you can leave it square root of 3, which is what I think they did, or you can type that into your calculator if you prefer a decimal, and you would get 1.73. Okay, either way is fine, and of course it's yards. I know that because my area is square yards. Okay, alright, number 15, parallelogram. Alright, they give us the area. They want us to find the base. How do you find the area of a parallelogram? Base times height. Well, the area is 120, so put 120 here. The height is 24, and the base would be B, so B times 24. Well, I mean, to me, these two are multiplying, so to get rid of the 24, we divide both sides by 24. If you do that correctly, you're going to get 5. 120 divided by 24 is 5, so 5 would equal your base. And of course, your area was in inches squared, so the base is 5 inches. Alright, 5 inches. Number 16. Okay, they want us to find the height of a triangle. Well, they give us the area, so we're going to write down the formula for area of a triangle. There it is. Now for area, I'm going to substitute 49. For 1/2, I'm going to leave it 1/2. For the base, I'm going to put 7. And for height, I'm going to put h. Now before we start getting h by itself, we can simplify this side over here. So let's quickly simplify the right side. 1/2 times 7 is 7 over 2. Okay? Now if you like decimals, you're welcome to put 3.5 if you want to. Alright? Let's divide both sides by 7 over 2. So 49 divided by 7 halves is going to give you 14. So divide by 7 halves, divide by 7 halves, and you'll get 14 equals h. Now the area is in centimeters squared, so the height would be centimeters. Okay, so really not too difficult. Moving on, the answer here would be 14 centimeters. Alright, moving on to number 17. On number 17, they give us a rhombus and the area. So how do you find the area of a rhombus? Well, guys, you learned this. Boys, y'all learned a lot this year, and I'm proud of what you've accomplished. But it's not easy sometimes to remember all this. But, guys, you learned that a rhombus 27. Then 1/2. One of the diagonals is 6, and the other diagonal would be D. Now we can simplify this side. So 1/2 times 6 is 3. Now divide both sides by 3, and 9 yards would equal your diagonal, your diagonal. So your other diagonal is 9. Okay. All right, moving on to number 18, a trapezoid. Okay. So they give us the area of a trapezoid right here. Well, the formula for the area of a trapezoid is 1/2 times the base, times the height, times your two bases added together. So let's fill in everything we know. The area is 56. The height is 4. Now your two bases, one is 8 and one we don't know, so we're going to say 8 plus b. Let me pause and say this. Let me get a drink here. Now whether you've had Algebra 1 or Algebra 1 and Algebra 2, this type of a little more complex equation should not even slightly freak you out. Guys, you should know what to do. Just step by step by step. First of all, you have 1/2 times 4, so multiply it together. You get 2, then bring down your parentheses. Next, take your 2 and distribute it or multiply it through, like you've been taught to do. Very simple. 2 times 8 is 16. 2 times b is 2b. Now, we've simplified both sides as far as they go. Now you're ready to get b all by itself, okay? So take the 16, bring it over, and make it negative. If you do that, you're left with 40 equals 2b. Bring the 16 over, make it a negative 16. It's gone. 56 minus 16 is 40. Now divide both sides by 2, and you get 20 equals b. I know it's meters because my area was meters squared. So your other base was 20. Alright, now a lot of you might be skipping these formulas and doing these in your head, and that is totally fine, okay? That's up to you. Alright, do whatever's easiest for you. Number 19. Alright, now, area of a rectangle, well, guys, we know that's either length times width, or you can call it base times height if you want to. Okay, so the area they give us is 6.25. The base we don't know, and the height is 5. So these two are multiplying. Divide both sides by 5 to get b by itself, and you'll get 1.25 millimeters. Okay, you know it's millimeters because your area was millimeters squared. So 6.25 divided by 5 is 1.25 millimeters. Okay, moving on to number 20, a kite. Okay, now guys, by definition, a kite always has perpendicular diagonals, always. Okay, so if we have a quadrilateral that has perpendicular diagonals, then we use this formula right here. 1/2 times the two diagonals. So the area is 56. So I'll put a 56 right here. One of my diagonals is 14. So I'll put a 14 here. And my other diagonal is just D. Okay, we can simplify this side over here. 1/2 times 14 is 7. Now divide both sides by 7, and you will get 8. 8 equals D. Of course, it's feet because my area was in feet. So the answer is 8 feet. Alright, moving on to numbers 21 through 24. These will be very interesting. We'll see if we can figure these out. Out of all four, I believe 22 is the most difficult one. Okay, 21. Find the area of an equilateral triangle with sides of 12. Okay, here's my equilateral triangle. I have a 12, a 12, and a 12. Now, that is called a regular triangle, or an equilateral triangle, or an equiangular triangle. There's two ways to solve this. One way to find the area of a triangle is 1/2 times the base times the height. Another way to solve or find the area of this triangle would be 1/2 times little a times capital P, I believe. Yeah, that's correct. Now, it really really doesn't matter which one you use, okay? And by the way, we know B and H are base and height. Over here we have the apothem or the apothem. I've heard it pronounced both ways. So I kind of go back and forth, okay? It's kind of like, well, never mind, it's another example. But anyways, apothem or apothem, whatever, or apothem or apothem. But anyways, I'm going to go with the more familiar formula. I think it's just easier that way. So here we go. I know the base of this triangle is 12. So where my base is, I'm going to go ahead and put a 12. What I'm missing is the height. I don't know the height. So I'm going to draw a height down. Now because it's an equilateral triangle, this height will cut this side in half. So I have a 6 right here. Also, this is 60 degrees. Well, it cut 60 in half. This is 30. This is a right angle. Students, look what I have. I've got a good old-fashioned 30, 60, 90 triangle right here. Do I not? Sure I do. So I'm going to put this 6 right here. So look, it's so easy. We always know that, well, here's 30, so go across, this is your shorter leg. Here's 60, go straight across, this is your longer leg. Here's your right angle, this is your hypotenuse over here. The shorter leg is always half the hypotenuse, or the hypotenuse is always twice as big as the shorter leg. The longer leg is always the shorter leg times square root of 3. So this height right here, this longer leg would simply be 6 square root of 3. Okay, look how great it is to know your shortcuts for your 30, 60, 90 triangles. Now, if you want to look at this right triangle right here and use Pythagorean's theorem, that would be totally acceptable. It's just faster. You would say I have a leg squared plus a leg squared equals hypotenuse squared. Okay, solve that, you'll get the same thing. All right, so here we go. My height is 6 square root of 3. Well, 1 half times 12 is 6 times 6 square root of 3, and 6 times 6 square root of 3 would be 6 times 6, 36 square root of 3. Let's see if they left their answer in that form. Or, okay, they have it both ways. So you can leave your answer like this. Of course, it'd be centimeters squared. Or you can type into your calculator and get a decimal. Okay, whatever you prefer. Now, this one's going to be really, really interesting. I've already worked it out. Now watch. They want you to find the length of a side of an equilateral triangle. Whose area is this? So I'm going to draw my equilateral triangle very carefully. I'm going to draw my height right here, okay? Now, I'm going to call this side S because I'm just so creative with my letters. S for side. So that means this side here is what? S over 2. I'm going to put 1 half, well, S over 2 is fine. S over 2, alright? Now, if this side here is S over 2, remember, this is a 30, 60, 90 triangle. How do I know that? Because we have an equilateral triangle. An equilateral triangle is also an equiangular triangle. So all of these angles are 60, 60, and 60. So I cut 60 in half and put 30. This is 90. Now, if this is S over 2, then my height right here would be S over 2 times square root of 3. I just showed you that in the last problem. Remember, anytime you have a 30, 60, 90 triangle, you take the shorter leg, multiply it by the square root of 3, and that gives you the longer leg, in this case the height. So now that I've labeled everything, I think we're kind of ready to try this, okay? Let's see if we can find the side. Alright, first of all, the formula is area equals 1 half base times the height, correct? My area is 16 square root of 3 equals 1 half times my base is, now be careful, your base is not S over 2, okay? The entire base of this triangle is S. All of the sides are S, okay? So my base is S, and my height is S over 2. Actually, I'm going to simplify that. Here's your height right here. Your height is S over 2 times the square root of 3. Well, how about if we do this? Let's put S over 2 times and put square root of 3 over 1. How's that? We can do that. We can put this over 1. So now I have S square root of 3 over 2 times times 1 is 2. No, don't think your S's are 5s. Okay, put a little line right here. Your S's are S's. Okay. Now we can solve for S. It looks complicated, but again, if you'll take a deep breath, relax, and think, you can simplify this side over here. Look, put the S over 1. Why would you do that, Mr. Earhart? So now you have fraction times fraction times fraction. So now you can take top times top times top times bottom times bottom times bottom. So I would have 16 square root of 3 equals 1 times S square root of 3. So 1 times S is S. S times S square root of 3 would be S squared square root of 3. Now, 2 times 1 times 2 is 4. Look at that. We're cruising right along. Now, you should know by now, whenever you're trying to get S by itself, if you have a fraction and a number down here, you want to multiply both sides by the denominator. So, I've simplified this right side as far as I can. Now I'm trying to get S all by itself. So, I want to get rid of this 4. Multiply both sides by 4. If you multiply this side by 4 over here, you will get 64 square root of 3. Let's look at it over here. 16 square root of 3 times 4. Multiply outside number with outside number. You get 64 square root of 3. Multiply this side by 4, and you're left with S squared square root of 3. Now look, it's so easy. You're trying to get rid of the square root of 3, right? So you would divide both sides by the square root of 3. This cancels. This cancels. You're left with 64 equals S squared. Now, students, take the square root of both sides. The square root of 64 is 8. The square root of S squared is S. You're finished. You did it. So S, this whole length right here is 8. S equals 8. 8 feet because area was in feet. Alright, number 23. They want us to find the area of a regular hexagon. Now I can draw one of those because I have a cheat thing here. Hexagon, there we go. Alright, let's try to get a regular hexagon up here. Now, we have a regular hexagon with an area of 5 meters, or find the area of a regular hexagon with a 5-meter sides. Now, a regular polygon uses this formula right here. We've already talked about 1/2 times the apothem times the perimeter. Okay, so let's first of all find the perimeter. Well, that's easy. 5 plus 5 plus 5 plus 5 plus 5 plus 5 gives you 30. So 1/2 parentheses for A and then parentheses for perimeter. I'll put a 30 right here for the perimeter. So the only thing I'm missing is the apothem or the apothem, and I'm going to find that. Remember what it is? Do y'all remember what it is? It's the distance from the center to a side. So this perpendicular, by the way, the apothem will always divide this side in half, always. So this side here is congruent to this side here. Now I'm going to go ahead and draw. Let's see. I want to find this height right here, okay? So I'm going to go ahead and draw this triangle here, okay? And I'm going to go ahead and draw this here. Now I'm going to show you why in a second, okay? Look, students. Inside this hexagon, I can draw 6 of these big triangles. 6. Okay? Now if I started right here and went all the way back to that same side, that would be how many degrees? 360. So, I have one angle here, one angle here, one here, one here, one here. 6 angles. If I take 360 and divide by 6, that means all of these angles here are 60 degrees. Okay? So that means this whole big angle right here is 60. So because I drew the apothem, that means this is going to be what right here? 30 degrees. So that's 30. I know this is 90. Hey, this is 60. It has to be because this is 30. This is 90. This has to be 60. Okay? So students, students, look at this. I know this side right here has to be half of 5, 2.5. So I have a 30, 60, 90 triangle that looks like this. I have a length here that's what? 2.5. I have a 60 here, a 90 here, a 30 here. Guys, this is the shorter leg. Here's your 30, go straight across. Shorter leg. All I have to do is find the apothem, the height right here. And that's the longer leg. Here's 60. This is my longer leg. How do you guys find the longer leg? Take the shorter leg and multiply it by square root of 3. Man, that was easy. That was fast. So right here, I'm going to squeeze in 2.5 square root of 3. Now this entire thing becomes one big calculator problem. So I'm going to take my calculator right now. I'm going to take 0.5 times 2.5 times square root of 3, close your parentheses, times 30, enter. I'm getting 64.95. And let me look in the book here. That is the correct answer, 64.95 square meters. Guys, I hope that made sense. Back it up and watch again if you need to. Be able to do these for the test. I might give you a bunch of these. A regular hexagon, a regular polygon. Always uses this formula right here for the area. Okay, let's try an octagon now. I'm going to be very humbled as I try to draw this in front of you. I have no idea what I'm doing, and you guys are probably used to that. 1, 2, 3, 4. So far I count to 4. It's pretty good. 5. 5, 6, 7. Wow, that's an amazing octagon. I mean, really, Mr. Lemon needs to fear for his position at Brian. I'm definitely going to become the art teacher. Alright, let's stretch this thing out so it looks even uglier. That is amazing. I didn't know I could actually do one that badly. Alright, so here's my cough regular octagon. Now, this side right here is 3/4, okay? So here we go again. If I want to find the area of a regular polygon, it's 1/2. A, little a, capital P. Now, let's find the perimeter real quick, okay? The perimeter is going to be 3/4 times 8. There's 8 sides. So with my calculator, I'm taking 0.75 times 8. That gives me 6 exactly. Alright? Now, let's find the apothem. So I have to draw right to the middle of the side. Like this. Now, before I do that though, let's do something else. Let's see what these triangles are going to add up to. Remember, I can draw 8 triangles in here because there's 8 sides. Count the triangles if you want to. 1, 2, 3, 4, 5, 6, 7, 8. 8 triangles. So I know I have from here to here 360 degrees. So I'm going to take 360 and divide it by 8. And I'm going to get 45 degrees. So this middle angle right here is 45. Got it, students? But I'm going to draw this line right down the middle. It's going to cut that in half. So now I have, it's really hard to write here. I'm going to put out here and draw an arrow. I have 22.5 degrees for this angle right there. Okay? In fact, it'd probably help if I took this triangle right here and just made it bigger over here. So here's the triangle bigger. Alright? Here's my right angle right here. Here's my right angle right here. Now remember, this whole side is 3/4. So if you take 3/4 and cut it in half, you're going to get 0.375. So this length right here is 0.375. Now, this is 22.5 degrees. Now, if you take 22.5 plus 90 and subtract from 360, I think you get 67.5. Let me check that real quick and make sure that's right. 67.5 plus 22.5 is, 9 degrees. Okay, so this angle's 67.5. Now, this is the side I'm trying to find. Now, don't you wish we had a really nice, pretty, one of our special triangles, 30, 60, 90, or 45, 45, 90. I wish we did. We don't. There's a point right here. Make sure to put that in So we're going to have to use sine, cosine, or tangent. Now, I'm looking for this side here, okay? I'll call it x. It doesn't matter which angle you circle, students. Please believe me on that. I'm going to circle this angle because I feel like it. So circle that angle, go straight across. This is my opposite side. Here's 90, go straight across. Here's my hypotenuse. So the leftover side is my adjacent side. So here we go. I'm trying to find this side, x, and I know this side here. So I need a trig ratio that uses opposite and adjacent. Well, that's tangent. So I'm going to say the tangent of 67.5 equals opposite x over adjacent 0.375. Now, tangent of 67.5 is an actual number, okay? And it's going to give me 2.41. So 2.4142 equals x over 0.375. Next, I've taught you guys, you have a fraction over here, multiply both sides by the denominator, in this case 0.375. So now we have 0.905, but 0.91 equals x. So now we know the apothem, or the height of this side, 0.91. So I'll put that right here, alright? So I have 1/2 0.5 times 0.91 times 6. And the answer I'm getting is 2.73. Now the book has 2.72, so we're good enough. 2.72 inches squared. Alright, okay. Moving on to 25. Numbers 25 through 28. The directions stated find the circumference and the area. So this will pretty much be calculator problems. Here we go. In order to find the circumference of a circle, we're going to use pi d. To find the area, we're going to use pi r squared. Alright? So I'm going to go really fast through these. I don't think most of you will probably need help on these, but just in case, I'm going to make sure, okay? So here we go. Circumference equals pi times 28 if the radius is 14. The diameter is 28. So 3.14 times 28 is going to give me 87.92. So there's the circumference. 87.92 centimeters, not squared. Not squared because it's not an area. Okay. Alright, the area would be 3.14 times 14 squared. So here we go. 3.14 times 14 squared gives me 615.44. And that would be centimeters squared. Okay, gonna go fast through these, guys. All right, number 26. In order to find the circumference, we're gonna say 3.14 times 2.8. If the radius is 1.4, then the diameter is 2.8. So 3.14 times 2.8 gives me 8.792 feet. 8.792 feet. The area would be 3.14 times 1.4 squared. So here we go. 3.14 times 1.4 squared. 6.1544. So 6.1544 feet squared. Moving on to number 27. Let's see what we have here. Alright. We're going to find the circumference quickly. The circumference is 3.14 times the diameter, which is 9. So 3.14 times 9 gives you 28.26 yards. Not squared. It's not area. Over here to find the area, 3.14 times. If the diameter is 9, the radius would be half of that. 4.5 squared. So 3.14 times 4.5 squared is going to give you 63.585. 63.585. So square yards. Alright, number 28. In order to find the circumference, we are going to So 5.6 squared. So the area is 3.14 times 5.6 squared. 98.4704 meters squared. That would be the area. Alright. Now numbers 29 through 32. The directions say to find the arc length and the area. Okay, so we're going to find the arc length and the area. Well, the first thing we have to do is find the circumference. Well, first of all, let's find the arc length first. The arc length, of course, deals with the circumference. Let's find the circumference of the circle quickly, okay? Let me go ahead and highlight that again. So I'm looking for this arc length right here. The circumference would be what? Pi times the diameter. 3.14 times 8. So 3.14 times 8 is 25.12. So the circumference is 25.12. Now, what fraction of the circle is this? What fraction of the circumference is this arc? Well, 35 over 360. So you take 25.12 and you multiply it by 35 over 360. Alright, I can do that very quickly. And let's see what we get here. 2.44. Alright, let's see if that's correct. 2.44 centimeters. Okay, so there's one answer. So the length of this arc right here, this arc length is 2.44 centimeters. 2.44. Now, let's move on and find the area of this circle. So the area of the circle would be pi r squared. So 3.14 times 16 would give us 50.24. So there's your area. Now that's the area of the entire circle. Okay? Now to find the area of the sector right here, we're going to multiply it by, well, what fraction of the circle, what fraction of the area is the sector? Well, 35 over 360 once again. So 50.24 times 35 divided by 360 is going to give you 4.88. Now it's area, so 4.88 centimeters squared. Okay, good stuff, guys. Alright, number 30, here we go. Alright, we're going to find this arc length right here. Okay, so we first of all better find the circumference. The circumference equals 3.14 times 7.4, which would be the diameter. 3.14 times 7.4, and that would give you 23.236. So there's the circumference, 23.236. Now you take the circumference times what fraction this arc length is of the entire circle. And of course, if this is 62 degrees, this is also 62 degrees out of 360. So 62 over 360. So here we go. Times 62 divided by 360 would give us 4.0017. So just 4 inches is the arc length. 4 inches. Alright. Now let's go ahead and find the area of the sector. Alright. Now the area of the sector, of course, first of all, we're going to find the area of the entire circle, first of all. The area of the entire circle would be pi times radius squared. So 3.14 times 3.7 squared would give us 42.9866. That's the entire area. Okay. Now, what fraction is this area of the entire area? Well, once again, it's 62 over 360. So take this area here times 62 divided by 360 would give us 7.403. So 7.40 inches squared would be the area of that sector. That should be correct. Alright, moving on to 31. Now, first of all, I want us to find the measure of this arc length right here. So the first thing we're going to do is we're going to find the circumference of the circle would be 3.14 times 15.2. Alright. If the radius is 7.6, the diameter is 15.2, so 3.14 times. Would give us 47.728 times. Now that's your circumference. Now what fraction of the entire circumference is this arc length? 162 over 360. Alright, so times 162 divided by 360, 21.4776, so 21.48. I'm looking at the answer in the book, and that is correct. They have 21.49, close enough. Now, let's find the area of this sector here by first finding the area of this entire circle. Okay, so the area of the entire circle is pi r squared. So 3.14 times 7.6 squared would give us an area of 181.3664. Now you multiply that times the fraction of the entire area this sector is, and you'll get this right here. Alright, so times 162 divided by 360, and that will give us 81.61. So 81.61, it's area, so it's going to be meters squared. Okay, one more in this section. That'll be the end of the part 1 review sheet video. Okay, students, here we go. Let's find the arc length of this arc right here. Okay, well, first of all, we're going to find the circumference. Circumference would be 3.14 times the diameter, which is 24. So 3.14 times 24, the circumference is 75.36. Now we're going to multiply that by the fraction of this arc length in relationship to the entire circle, which is 118 over 360. So here we go, times 118 divided by 360, 24.70, 24.70 feet. So the measure of this arc length from here all the way to here is 24.70 feet. Alright, now let's go ahead and find the area of the sector. Okay, area of the sector. Well, first of all, let's find the area of the entire circle. The area of the entire circle would be 3.14 times the radius squared, so times 12 squared. So 3.14 times 144 gives us an area of 452.3016. Now, we want to find out just this fractional part of the entire area, so we multiply the entire area by 118 over 360. So here we go, times 118 divided by 360, and you get 148.21 square feet. There we go, and that should hopefully be the correct answer. Yes, it is. Close enough. Okay. All right. We'll stop there for part 1 of the review sheet help video. Hope it's been a help so far.